So in factoring, this lovely sheet here is your factoring sheet because it looks like factoring. I hope you figured that out. If not, we're in trouble. That this is the factoring, the other ones are out. But okay, we have product sum. Product sum. So you're going to have a little piece of paper beside you because it is not a challenge to fit it onto here. Product sum. Okay, we're going to do sum together, and then you're going to do sum. So the product sum page we're going to start on is not the decomp one. It's how can a fisherman save gas, that page. We're going to skip number 1 for a short tip. That's a difference of squares. We'll come back to that one. We're going to go to number 2 first. Number 2 is n squared plus 8n plus 12. So we're going to go dig to the deep, dark depths of math. Try and retrieve some of the stuff we learned. Okay? Now, when we do factoring, what we always did is we would take what multiplies to give us the outside and adds to give us the inside. Multiplies the outside, adds to the inside. Now, I always make you draw blanks. And some people are like, I'm lazy, I don't want to draw blanks. If you don't draw blanks, there's a much bigger chance you will find it harder and it will take you longer. So just humor me. Draw blanks. Okay? So, these are what the blanks look like. We're going to go what times what equals, and it's always these two numbers when they're multiplied. So with product sum, there's always a 1 in front. So technically it's what times what equals the back number, because 1 times the back number will always be the back number. But with decomp, you have to do the front and the back, so I just stick with the same thing. So what times what gets me 12, the outside. And then what plus what gets me the inside number. Now you have to take the sign with it. So plus 8. So what two numbers multiply to give me 12 and add to give me 8? Anyone got a guess? Yes.
6 and 2.
6 and 2. You are correct. So the reason why I do the blanks is because it should guarantee that you're not stupid after this point, right? Like you're like 6 times 2, 12. 6 plus 2, 8. Yes, I'm not done. I will get this. If you draw the blanks and you can get to this point, especially in product sum, you basically have the answer. You are golden. Because when it's product sum, when there's a positive 1 in front, if there's a negative 1 in front, this doesn't work. When there's a positive 1 in front, you can go right to blanks after this. So you can go this equals, and you put an equal sign because you're saying that this equals this. Equals blah, 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 right? When it's an expression means it doesn't have an equal sign in it. When it's an expression, you will always have an equal sign running down the left side. So this equals this, right? When it's an equation, when there's an equal sign in it, in the middle, the equal sign just runs down the middle, because that's where it is. But an expression doesn't have an equal sign. So we're saying that this equals the next one. And whenever you factored, if your teacher ever gave you a multiple choice question, you could have just foiled the answers back to the question and not known how to factor whatsoever. Because all we're doing is we're simplifying it into 2 factors. But those 2 factors you can foil, like first, outer, inner, last, and work your way right back. So whenever you're done factoring, in grade 10, you should have known if you got the question right or wrong. Because you can always work it back and see if you get the original. If you get the original, yes, you were right. If you didn't, go back, try again, right? So you can always double check factoring. So our variable is an n. So when we have a 1 in front, and this is the key thing, it has to be a 1 in front, we go right to 2 brackets. We put it, whatever that variable is, so an n in the front. And then we follow behind with the numbers we found. And the 2 numbers you found were plus 6 and plus 2. And we're done. And you guys thought your lives were really hard last year when this was fun. I don't know what happens over the grade 10 summer. It's like your brain's immature and you're like, well, that was easy. But like, things go poorly with brains in grade 10. I don't know. It's real. So is that bad? That's not hard, right? Now we could check it. Let's check it. So we're going to go back and remember foiling. So with foiling, we did first, outer, inner, last. So we went first times first, or basically every single thing in this bracket needs to get multiplied by every single thing in that bracket, right? So we do first times first. So n times n is n squared. Then outsides. N times 2 is 2n. Clay is so loud. And then inside, 6 times n is 6n. And then last numbers, so 6 times 2 is 12. Why is he so loud? And then we get n squared plus 8n plus 12, because we can put these ones together because they have the same terms, same variables. And you get the same question back, right? So whenever you factor, you should always be able to tell if you did it right or not. Okay? We're not going to be using factoring a lot right at the beginning of the year, but I go through it and review it, and then it pops up in daily quizzes so that when we need it in quadratics, which is chapter 3 and 4, you guys can do it. It's just easy. Okay? So, here it says, factor each polynomial below. Find one of the factors in each column. This is column 1, this is column 2. Notice the letter next to one factor and the number next to the other. Write it in the box at the bottom of the page. So our factors are n plus 6 and n plus 2. So if we look above this gray line above here, n plus 6 and n plus 2. n plus 2 is 11. n plus 6 is a. Do you see that? So I go to number 11 down here and I put an a. n plus 2 is 11. n plus 6 is a. So I go down to 11 and I put in an a. You see that? Up here, n plus 2 is 11, n plus 6 is a. So in 11 I put a. Does that make sense? So all these questions will come from this column, and then the next set of questions come from these columns. Okay? So let's look at number 2. We're not going to FOIL them all back. I just wanted to prove a point. Number 2 we did already, dummy. We're going to go to number 3. N squared minus 9n plus 20. And then I make a point of putting a 1 here, because if it's a 1 here, our life is substantially easier. We can do product sum. So we go off to the side, we do our blanks. What times what equals the outside 2? So 1 times 20 is 20. And then what plus what equals the middle, which is negative 9. What factors of 20? Two things multiply to 20. And when you add them, give you negative 9. Nikki? Negative 5 times negative 4. We need 2 negatives to make a positive, correct? And 2 negatives to make a negative when I add them. So it's going to be negative 4 and negative 5. Negative 4, negative 5, then I check them. Negative 4 times negative 5 is positive 20. Negative 4 plus negative 5 is negative 9. And I feel like I got this, right? Now, when there's a 1 in front, our life is good. We should throw a little party at all times when there's a 1 in front, because you can go right to brackets. Way less work. So what do I make sure I do? This is an expression. So this expression equals a new expression. What is my new expression? Well, I have an n squared in the front, so I put an n in the front of each bracket. And I can only do this when there's a plus 1 in front of it. And what follows behind? Minus 4, minus 5. Does it matter if I go minus 5, minus 4? Does it make a difference? No, because those two brackets are actually multiplying. And multiplying has a commutative property. Like, for example, 4 times 5 is the same as 5 times 4, correct? So if I go n minus 4 times n minus 5, or n minus 5 times n minus 4, it's the same as going 4 times 5 and 5 times 4. It's the same thing, right? So it doesn't matter what order you put them in. So let's go look. N minus 4, n minus 5. N minus 4 is 14. N minus 5 is p. So number 14 is p. Is that making sense? Try number 4. I'm going to write it down. You're going to try it. N squared plus 16n plus 64. Okay, let's see what we can do, even if you're not done it. So we're going to go, what times what equals, what number? What times what equals?
64.
64. And then what plus what equals? Positive 16. What two numbers? 8 and 8. Did you know that when these are 8 and 8, when these are like this, it's called the perfect trinomial square. Perfect trinomial square is a fancy way of saying two factors come out the same. Okay. So we're going to get n in the front of each bracket, and then plus 8 in the back. Anyone know how else I could write that? Yes, got it to you. n plus 8 squared. All right, so when you get two that are the exact same, you can write them squared, because it means you have two of them. And that was why in polynomials in grade 10, you were always taught that when you had it to a 2, to always write it out twice, so that you actually FOIL it, and don't just square the front 2 and square the back 2. Because what happens when people get it like this, n plus 8, is they'll go, oh, that's n squared plus 64. But was it actually n squared plus 64? No, it's n squared plus 16n plus 64. So whenever you see something like this squared, always cross out the squared and write it out twice. You'll make way less errors. Okay? N plus 8 and n plus 8 is 2 and y. So your number 2 should be a y. Number 5, we have n squared plus 2n minus 15. Try that one out. So this one we're going to go, what times what equals 15, negative 15, sorry. And what plus what equals positive 2, what numbers? How much people had it right? 5 and negative 3. So you get n plus 5 and n minus 3. Which is 4 is O. We're going to go back to 1 just so that we can fill it in. It's totally different. It's a difference of squares. You should be able to spot a difference of squares, but we're not going to deal with them as much. So I'm just going to show you this one. A difference of squares is actually extremely well labeled. It's a difference, which means subtraction, of squares. 2 squares. That was like one, like Pythagorean theorem. What the heck's that? I don't know. This is a difference, subtraction of squares. I'm like, good. That's a very good definition. You just defined it in the words, right? So what happens when you have a difference of squares, and it has to be a difference, is you have a minus sign. So what's going to happen is you're going to get one of them with a plus in the middle, and one of them with a minus in the middle, because that gets rid of the middle term that they don't have. They don't have just like an n term. And then you just square root the front, put it in the front, square root the back, put it in the back. So if I square root 4n squared, what is that? Square root of 4 is 2, plus u squared and n squared is n. So I get 2n, correct? That goes in the front of both brackets. And then I do square root of 49 is, rhymes with heaven. It's a 7. That's it. So difference of squares is actually fast. You can spot them. 2 terms, never 3, right? It's a 2-term thing. It's a different sign. And you take the square root of the front and the back, and they should be perfect. If they have decimals, then you can't do anything. It's just, yeah, you can't difference of squares. So that one is number 9 is G. For now, we're going to skip all the difference of squares ones. So you're going to work on the other ones. I'm going to give you a little bit of time. So you're going to work on number 7. 10 is a difference of squares. 11. 16. I'll give you a little bit of time to try those ones. So these are the ones that are all product sum. Well, this one's a difference of squares, which is what we just did. If you get stuck, put your hand up. I will come help you. So if it's 1 minus 9a squared, some of you guys are saying, well, I want the a squared first. You can't want it first. It is where it is, right? So the rule is, for difference of squares, is I said we go to brackets. We do a plus, we do a minus, or we do a minus and a plus, doesn't matter. But whatever this is, the square root of 1 is 1. It's in the first spot, correct? So it has to stay in the first spot. You can't flip-flop them just because you want the variable first. Do you know what I'm saying? I know we always promote variables first because it's just nice-looking math, but you can't move it if it is that way. Whatever comes first goes in the front of the bracket. Whatever is last, 9a squared is 3a. Because it's second, it comes second. You don't have a choice. Make sense? So you have to put them in the order that they fall. You don't have a choice. So we do decomposition. If you can't believe what your brains can do, after decomp, we've done the entire factoring unit of grade 10. In about 20 minutes. It's crazy how things, the second time you see it, they just connect a lot better. Also, brains mature. So decomposition. You have to do decomposition whenever there's not a 1. If there's a 4, a 2, a 7, a -3, a -1 even, you have to decomp. So the only time you can get away with product sum going right to brackets is a 1. And the problem in grade 10 is some people don't realize decomp exists and they always try and go right to brackets. Well, if you go right to brackets, you'll always have a 1 in front because n times n is n squared, correct? So you can't just go right to brackets when the number in front is not a 1 because you're going to need to have a number there. Okay? So let's look at the first one, which is number 6. Number 6 has 3n squared minus 8n plus 5. Still follow the exact same steps for the blanks. That's why we did the multiply outside, add to inside. So we're going to go what times what is 3 times 5, so 15. That step didn't change. And then what plus what is -8 in the middle. Now decomp is hard if you actually don't know why the heck you're doing it. If you're just doing it because you're trying to memorize steps, in math, you're going to be in trouble, especially in grade 12, because so much of it you have to decipher through. You can get away with a lot of step-by-step stuff in grade 11, but in grade 12 you can't. So it's better to always understand why. So we still do the same thing. We multiply to give us the outside, adds to give us the inside. That did not change. Our numbers would still be -5, -3. We still set up with the same situation. The only difference is we can't just go right to brackets. If we went right to brackets, we'd have n minus 5, n minus 3, which gets us n squared, not 3n squared. Okay, so we can't go right to brackets. But what we can do is minus 5n and minus 3n. If I add n's to these, if I go minus 5n minus 3n, that actually equals minus 8n, does it not? Is that not a true statement? Do you agree with that statement? So why can't I just go to the minus 8n, toss it out, and replace it with those two? Can I do that? Is that true? Is minus 3n minus 5n minus 8n? Is that the same thing? So can I not just take this, toss it behind my head, and replace it with that? Aren't they the same? You just told me they're the same, correct? Are they not? -8n is the same as -5n minus 3n. Sure? So the only thing I'm changing out is this. Do you see that? The 3n is going to stay the same. So 3n squared stays the same. The plus 5 stays the same. I'm not touching that. I just found another two numbers I could put in instead of -8n. That's it. Which one would go better with 3n squared? The -3n or the -5n? The -3n. Does it matter? Could I put the -5n first? Sure, it doesn't matter. But if one goes nicer, I rearrange them. So I'm going to go, okay, I'm going to go minus 3n minus 5n. Because all I did was I replaced the -8n with these two. So it's the same thing, is it not? Do you see what I did? Understand what I did? Okay. Then in grade 10, you're taught grouping. And the only reason why you're taught grouping is so that you can do decomp. That's it. Because all we do is we do this first step where we do the what times what plus what, same thing. Second step, we replace that middle term because we can. They're the same thing. Third step is you just group the first two and you group the back two. Let me use green. So we group these two, and we group these two, and then I put a plus sign between those two brackets because there still exists a plus sign. Now I'm almost done. I just have to GCF out of my first bracket and GCF out of my second bracket, and hope to goodness that what's left in the bracket is the same things. So, what can I take out of this first green bracket? Ooh, that really went far. What can I take out of this first green bracket? Both of them have a 3, right? So I can take a 3 out, equals a 3. And then what else could I take out? An n. And then I put a bracket behind and write what's left over. So if I take a 3n out of 3n squared, what's left over? And when I take them out, GCFing, you're dividing. So if I take a 3 out of 3, the 3's gone. N squared, if I take an n out, I'm just left with a n. So 3n squared, take out a 3n, I'm left with an n. What about negative 3n, take out a 3n? What's negative 3n divided by 3n? Negative. When you divide two things that are the same by each other, what are you left with? A big ol' 1, right? So if I do negative 3n divided by 3n, I'm left with a 1. Now whatever I take out of this bracket, I have to be left with n minus 1 in the bracket, because the brackets need to match. It's part of decomp. So what can I take out of negative 5n plus 5? I can take out a 5. If I take out a 5, though, I'm left with negative n plus 1, and I need positive n minus 1. So instead of taking out a 5, what should I take out? A negative 5. Then when I go negative 5n divided by negative 5, I'm left with a positive n. And then 5 divided by negative 5, I'm left with negative 1. Do you see that these brackets match? If you don't know this, this is one term and so is this. The terms are connected by plus or minus signs. So the reason why we want these brackets to be the same is I can GCF an n minus 1 out. They both have an n minus 1. I can take an n minus 1 out. And then what's left over? 3n minus 5 makes up the other factor. If I FOIL these back, I'll get 3n squared minus 8n plus 5. So your first step with decomp is still do what times what gets you what plus what gets you what. Then you replace the middle term, then you group, then you GCF. So you have to do a lot more steps when it's not a 1 in front. That's why I said throw a party when there's a 1 in front. So for this one, n minus 1 and 3n minus 5 is 18 is S. 18 is S. So then we're going to look at number 8. (5a squared plus 9a minus 2). So we still started the same. What times what gets me the outsides? So 5 times negative 2 is negative 10. What plus what gets me the inside, which is positive 9? Anyone know the two numbers? Multiplies to give you negative 10, adds to give you positive 9. Positive 10 and negative 1. Often if you're stuck, it's the 1 in the number. Like people, if it's 5 and 2, you guys be golden. Whenever people are stuck and don't know what to put in the blanks, it's usually like 10 and 1, 5 and 1, 4 and 1. It's when it's the 1 times the number. You guys like don't forget, remember that's a factor or something. It's cheesy. So this one is 10 and negative 1. Now I need to go replace 9a. If I go 10a plus negative 1a, it's going to be 9a. So I can go and replace this with 10a plus negative 1a. So the first part stays, 5a squared stays, negative 2 stays. And the middle gets replaced with, instead of the 9a, I take the 9a, I rip it off my board, I toss it behind my head, and I replace it with positive 10a plus negative 1a. You see how the front and back stayed the exact same, but the middle got replaced? Because you can. They're the same thing. What do I do next? Do you remember? Rhymes with fruit. Starts with a G. Group. I was going to have to spell it next. You group. So we group our first two. We group our back two, and we make sure there's still a plus sign sitting between those two brackets, right? And then we see, can we take out a GCF? What can I take out of 5a squared and 10a? A 5 and a. 5a squared divided by 5a is a plus sign. 10a divided by 5a is what? What's 10a divided by 5a? 2. And what can I take out of the last bracket? Because I know that whatever I take out of that last bracket, I better have a plus 2 left over, right? Because I need to have the brackets match. So I have negative a minus 2. And I need to be positive a plus 2. So all I can take out is a negative. So negative 1. I take a negative 1 out of, it just changes signs, right? Whenever you take a negative 1 out of anything, signs change. So negative 1a divided by negative 1 is a. Negative 2 divided by negative 1 is plus 2. And then I get the brackets once, a plus 2, and then what's left over? 5a minus 1. A plus 2 is 7, 5a minus 1 is L? Or is that an I? I think it must be an I. It's all capital letters. So 7 is capital I. You guys are going to try number 9, see how you do. Try number 9, then we're going to go through it. Okay, so for this one we go what times what equals 30, front and last. What plus what equals 11. It's going to be 6 and 5. And then we'll get 6a plus 5a equals 11a. That's what I can replace this with. So I get 2a squared, and then instead of the 11a, I get plus 6a plus 5a, and then the plus 15 sits at the back. You take a 2 and an a out. 2a squared, take out a 2a is an a, plus 6a divided by 2a is 3. Now whatever I take out of 5a plus 15, I have to be left with a plus 3. So I can take a 5 out of both, a plus 5, and then I'm left 5a, take out a 5 is a, plus 15 divided by 5 is a 3. And then I get a plus 3, and then what's left over, 2a plus 5. So 16 is O. Okay, I'm going to get you guys to try these, and if you get stuck, please put your hand up. We're going to go through them anyways. But I want you to try 12. Try 12 and 14. 12 and 13 for now. If you're somebody who's like, I'm so awesome at decomp, I'm like the best decomper in the world, you can work through them. And we're going to work on the second page. So if you're like, I'm so awesome, let me keep going, you can.
With this one, if you factor this out, then that would be 5.
This is 5A. I'm still an A. So you need to put 5A and
Oh,
25A
yeah.
there. Then it'll work.
So would this not be
It's the negative 2.
negative 2?
And then your signs can be right. Big hint, 99% of the time, if this one is negative, you're going to take a negative out.
Yeah.
But the odd time you still have to, but only if you're like the leading coefficient is negative. Because if your leading coefficient is positive, it's always going to have to be positive.
Okay.
No way you can throw it right.
Okay. Yeah. Thank you.
into the wrong room. It's disgusting to adjourn. Oh, good. I've been leaving that run the whole time. That's not boring. Okay. So 12 is 10a squared minus 3a minus 1. What times what equals negative 10? What plus what equals negative 3? So it's negative 5, positive 2. So negative 5a plus 2a equals negative 3a. So I get an equal sign. 10a squared minus 5a plus 2a minus 1. And then I group. So the plus sign stays in the middle. Then I can take a 5a out. 10a squared divided by 5a is 2a. Negative 5a divided by 5a is negative 1. And then this actually is the exact same as this. So if this second bracket is the same as the bracket, you just take out a plus 1. Because that's all you can do. You can't take out anything, right? So you write plus 1. So if this bracket already matches it, you just put a plus 1. 2a minus 1. Because you still need a number to go with that other number for the factor. So I get 2a minus 1 and 5a plus 1. Which is 5 is R. And then 13, I'll do it down here. Oops. Thirteen is 8u squared plus 19u plus 6. I go what times what equals 48? What plus what equals 19? 16 and 3. So my 8u squared stays the same. My 19u gets replaced with 16u plus 3u, and then plus 6. And then we group. So 8u. I take 8u out of 8u squared. I'm left with u squared. Not u squared. And then 16u, take out an 8u. I'm left with a plus 2. And then here I have to be left with u plus 2. So I have to take out a 3. 3u divided by 3 is u. Plus 6 divided by 3 is 2. And I'm left with 8u plus 3 and u plus 2. Which is 15 is O. So I'm going to have you do 14, 15, 17, 18, and we'll go through them, and homework is the back page. There's 10 of them. For the back page, it literally just says factor each trinomial below, find both factors in the rectangle below. You will cross out 2 boxes for each exercise. When you finish, print the letters from the remaining boxes in the square. So it's different. You have to cross off what you find, and then what's left over will make up the word. So, you know what I mean? 2 factors, cross them out. I would use pencil. So you're going to do 14, 15, 17, 18, and we're going to go through them, and then homework is the back. So if you're done those ones already, you can work on the back. Isn't it? 42. Oh, 15 and 4, 30 and 2, 6 and 10, 20 and 3. There we go. Oh, this far. I don't know, what is the saying? How can a fisherman save gas? What does it say on the bottom? By what?
Forming?
By forming?
Yeah, forming
By forming carp pools, of course. How does it? Carp pools? Carp is a fish. By forming carp pools? Carp pools? I didn't say it was good. I said it was real. By forming carp pools. Carp pools. So your homework are the 10 questions on the back.
Can we run into it? Take a picture of this one, please.
Nope. Just this side. So when you hand in your homework for Friday, when you're done it, you just take a picture of. You take a picture of the work, so you might not even take a picture of this. It might just be your work on a separate sheet of paper too. But I need work. I can't have, I'm not going to just take the picture. Like, if you just take a picture of this with these all boxed out, I'm going to say you copied off somewhere. At the very least, copy their work.
Make lessons.
At least I'm making you do some work. Because that ain't going to work. Like, I won't accept that. Just cheat. Wow. Just kidding. Don't cheat.
I agree.